On behalf of the Ashden Awards, I'd like to welcome everybody here. It's tremendous to see you all, and I hope you'll have a really interesting day. We're running this seminar for the third year running in collaboration with Imperial College. It's been a fantastic collaboration from our point of view, and I'd like to start just by welcoming Professor Sir Peter Knight, who's the Principal of the Faculty of Natural Sciences at Imperial College, to open the seminar. Peter.
Thanks. It's really wonderful to see you all here at Imperial. We're very proud to be able to be associated with you. If you've had a look at some of the poster displays outside, you will see that looking at sustainable and renewable energy and the effects on the environment is one of the major activities within Imperial. So my job, by the way, is to run all of the science departments here. I'm actually a physicist, but it means I also have to look after the biologists, the biochemists, the ecologists, the environmental policy people, and so on. And within this building, for example, there is a major effort to look at next generation biofuels, looking at lignin digesters. In the next door building is a major effort to look at ways of reverse engineering photosynthesis to generate hydrogen by splitting water. Elsewhere, there's an awful lot of activity on photovoltaics, fuel cells, solar cells, and the like. And I hope that you'll have an opportunity to explore some of those activities during your day here. It's a great day to be looking at activities in this area. Today is the day where the UK government launches its new major initiative called Living with Environmental Change. So you have some competition today. So at lunchtime, the Science Minister is launching the LWEC initiative, which is bringing tens of millions into the area of environmental change, mitigation technologies, renewables, and so on. And that's why you won't see me this afternoon. But I hope you enjoy your day. I've been asked to say a few things. In the event of the fire alarms going off, and they rarely do in this building, there are exits there, and of course 2 at the back, and that will get you out of the building very rapidly. The other thing I should mention is that if you possibly could, turn your mobile phones off. You are in a concrete bunker, but nevertheless you will get a signal. So if you could either put it on to quiet or to turn it off, I think the rest of the participants would really appreciate it. So let me say something about Imperial. Imperial is, those of you who don't know Imperial, we are a university solely devoted to science, engineering, and medicine. So by international standards, we're quite small. We have about 14,000 students, but we're tremendously international in our scope, with a very large number of students from around the world studying here at Imperial, especially for postgraduate degrees. About 40% of our students are doing postgraduate work. We have the largest medical school in Europe. We've got a very large number of hospitals we look after in West London. And looking at ways in which, for example, environmental change is modifying health around the world is one of the major foci of our medical schools. Within engineering, as I mentioned, there's a great deal of activity on renewable energies, on green energy and the like. Within our natural sciences area, the idea of environmental change is at the heart of our strategy. I hope you can look at some of our exhibits outside in the corridor. I've had a look at yours inside, both the UK and the international ones, while we were setting up this morning. And I'm absolutely stunned by the range of things, the depth of things, and the impact this is going to have on people's lives. This is the 6th, I think, of the Ashden Awards. The 8th. Okay, the 8th of the Ashden Awards. And I think that year by year you can see this growing into something of real importance to the world. I hope you have a really great day. I should be along for the awards thing tomorrow at the Royal Geographical Society, which is our neighbour up the street. The reason we're all here, by the way, is the great exhibition in 1851, organised by Queen Victoria's husband, to exhibit what was going on in technology around the world, made such an enormous profit, 1/3 of the country came to it, that the Prince Consort bought the entire site from the park down to the Cromwell Road for the encouragement of the practical arts. So the Great Exhibition trustees own the Royal Geographical Society, Imperial College, the museums and so on. And part of this whole process of looking at the way that the Albertopolis site here interacts with the outer world is really very important to us. Ashden is part of that, I hope. I hope to see you here next year and for many years thereafter. But really do enjoy your day. But remember, turn your phones off. Thank you.
Thank you very much, Peter. And I'd just like to hand over to Dr. Keith Pullen from the City University and the founder of the NGO Developing Technologies, who will chair the first session today. Keith.
Thank you. It's a privilege to chair this first session. I'm actually an alumnus of the college, and I also run an organisation developing technologies. I won't say too much about that. There's going to be a seminar at the end of the day at 4:20. So if you're interested in that, please look at the posters or come to the seminar, which for the where we're meeting the international finalists, but also everyone else is very welcome. So without further delay, we have a rather tight schedule. So I'll introduce our first presentation, which is from the Kisangani Smith Group in Tanzania.
Njombe, in the highlands of southwest Tanzania, is one of East Africa's timber centres. Here and across the region, people in towns depend on charcoal for cooking. But charcoal is expensive, and production causes pollution and leads to deforestation. To answer these problems, a unique technology has been developed locally. No engineering degree required, just homegrown initiative and a passion for design. The Kisangani Smith Group is a collective of blacksmiths dedicated to giving unemployed youths a future. Founder member is Reuben Mtitu.
We aim to give them an alternative to falling into street crime and a way of becoming self-reliant. Blacksmithing is quite easy to learn and the basic toolkit is cheap, so it's easy for them to get set up back in their villages.
Blacksmithing depends heavily on charcoal. In an attempt to get an independent fuel supply, they started a sustainable forestry project which got them wondering how to conserve the timber. Once local wood has been sawn into planks, it's sent across the country and East Africa. The byproduct has created a river of sawdust. Sometimes it's burnt as waste, but more often it's left to rot.
I started to think, after I'd seen people burning this waste, that I should make a stove that people could use to see whether there was any way to put it to good use.
Reuben and his team got thinking. Loose sawdust burns unreliably, so they needed a way to turn it into an efficient fuel. The design they came up with relies on two essential accessories.
You fill it up, but first you put this stick in the middle, and then you fill up the sawdust around it, then compress it.
Without too much effort, the filling tool produces something like a sawdust briquette that burns slowly and evenly.
Then you take it out and carefully remove the stick, leaving the hole that will let the air into the middle.
The air comes through a side inlet and is drawn up through the centre of the sawdust. Once it's lit, it burns for up to 6 hours. The top of the stove is designed to spread the heat evenly so it doesn't burn the pan, and after lighting it's almost smoke-free. This pan of water took about 20 minutes to boil. Stoves are made using a simple template. Most of the work is done by hand. The parts are cut from a sheet of mild steel, and using a hammer skillfully, parts are shaped, joints created, and rivets fabricated. As there is a little drilling and welding, mains power is needed.
very simple to make it. It's not difficult, and it is simple to use it.
Stove sales have taken off in Njombe as people have seen the advantages of using sawdust. With no charcoal fuel bill, the purchase price is usually recovered in about 4 months.
Since I bought the stove, I don't have any expenses. That's why I like this, because when I was using the charcoal stove, the costs were high. And now that I use this stove, it helps me in many ways. I start in the morning about 6 o'clock when I wake up. I heat water for us to wash, and then I cook breakfast. And at 1 o'clock for lunchtime I cook my beans. And the stove is still on.
I cook everything, rice, beans, donuts, using just one stove. If you put a bit of firewood in the vent, it gets hotter and cooks things quicker. When I use charcoal, it gives me a headache if I stay a long time in the kitchen. With this one, I don't get headaches anymore because it doesn't produce any smoke.
But how do you cut down on charcoal if you don't live near a sawmill? The good news is they've been experimenting with other everyday waste materials for fuel.
But in other places where wood isn't being sawn, the good thing about it is that you can use rice husks. It's a great stove because you can use it in any areas where you have products like these.
They've sold over 3,500 stoves, some for sawdust and some for burning wood more efficiently, many of them to wholesale traders elsewhere in Tanzania. But that's with very little marketing. The group now wants to publicise their technology and scale up manufacture.
We also want to be able to sell them at a good price so people on low incomes can be able to afford them. The Kisangani Smith Group would like to produce the stoves in large quantities so that people can use them in their villages without destroying the environment.
So just to mention before the presentation, we'll have questions at the end after the third presentation. So I can just introduce to you John and Reuben Mtitu.
My name is John Gustav Mtitu. I'm working as a technical officer at Kisangani Smith Group, Tanzania, East Africa.
Naitwa Reuben Mtitu, mwenyekiti Kisangani Smith Group.
His name is Reuben Patrick Mtitu. He's a chairman, Kisangani Smith Group. Yeah. Yeah, stop. Yeah. Kisangani Smith Group is a volunteer set up in 1996 by Vincent Mtitu and Reuben Mtitu and other members. Named after Vincent Mtitu, grandfather, Kisangani Smith Group had trained him as a blacksmith. Mission is to elevate through appropriate technology, focus on unemployed young people as a blacksmith metal workers. We are training the youth at our workshop in Njombe, as you saw in the picture, and we are using blacksmith technologies to train the youth. Here is our workshop, village blacksmith need charcoal. It is possible to make small agricultural tools, workshops, without electricity, but charcoal is essential. A large-scale use of charcoal is a major cause of deforestation. KSG ways of reducing deforestation: planting trees, restored existing forest is about 124 hectares so far. Developing stoves that burn sawdust and other agricultural waste to replace charcoal and other that burn wood more efficiently is about 3,500 stoves so far. Sawdust stove manufacturer. We produce sawdust stove as you see on the photo. A sawdust stove in use. Women are using the stoves and are happy to use them. Here is our workshop, and even women are involved in making the efficient stoves. Wood stove in use and used in rural areas. Here is a place where we expect to install mean hydroelectricity. And Jatropha plant is also one of our activities. Thank you for listening.
Tremendous contribution to the development of sustainable stoves. Thank you very much. Our next presentation is from the Gaia Association, Ethiopia.
Kebrebeya refugee camp, eastern Ethiopia. This single camp is home to over 17,000 Somalis who fled their homes in the civil war. This region has housed up to 600,000 refugees. For the past 20 years, the refugees have collected firewood for cooking from the surrounding countryside. It's now 99% deforested.
The area is deforested due to the presence of refugees. You can clearly see how to get the firewood, how it is challenging and laborious work, especially for women and children who are the primary responsible for collecting firewood.
I've been living here for 17 years, and we have to travel long distances to collect firewood. It's not a good way to live with this firewood inside our kitchen. It irritates our children's eyes. The smoke gets everywhere in the house.
Fuel wood emits dangerous levels of carbon monoxide and smoke, and for the women who have to walk for hours to find wood, there are other dangers.
One day, 4 of us were collecting firewood. 3 of the women ran away when the landowner appeared with a dog. I was left alone as I had stopped to tie my scarf. He caught me and beat me with a big stick.
Imagine the environment's damage. Daily, every refugee cuts wood for, for cooking purpose, for construction purpose, and Ethiopia has, paid a lot of sacrifice.
The hunt was on for a solution, and by coincidence, the Ethiopian government was looking to get rid of a waste product from the sugar industry, molasses.
They were dumping the molasses, which is the raw material for ethanol production, and they had the capacity to produce ethanol, but they didn't have anywhere to sell it.
Luckily, there was an off-the-shelf solution that could permanently solve both problems: a camping stove. Work began with a trial, giving the Swedish-designed clean-cook stove to a few refugee households and some in Addis Ababa. After the success of the trial, the Gaia Association was formed to distribute the stoves.
So this is how it started. When the idea came to Ethiopia, we did really a thorough pilot studies in different refugee camps.
After the trial's success, the stoves are being distributed to all the other women. They are easy to use and safe. The ethanol is absorbed by fibre wadding in the canister, so there's no chance of dangerous spills, even if the stove is turned upside down. Word has spread about the stove's benefits, and all the women are keen to improve their cooking conditions.
We always eat clean food now. We no longer have smoke irritating our eyes, and our houses are clean and don't smell of smoke anymore. So we are thankful to Gaia. We are really pleased with the ethanol stoves.
The refugees are so poor, they often sell their possessions to make ends meet. But the stoves are so popular, they never appear for sale in the local markets.
If we provide plastic sheeting, they sell it. Even the ration, they sell and buy something else. But the stove, they keep it. And this is an indicator for us to what extent they really love the stove.
I'm pleased. I think this will be much better than firewood. My life will improve, there's no smoke, and I won't have to collect any more firewood.
As a result of having the ethanol stove, they have ample time now to do some income-generating activities. Now they even have time to go to the health center, and plus, it reduces the impact on the environment, which means the tension between the locals and the refugees is reduced.
Stoves have now been distributed to all refugee households in Kebrabea, benefiting over 17,000 people. But the stoves are not limited to poorer households. People living in the new blocks of flats in Addis have also tried out the stove. Gaia now has an order for 2,000 stoves for the flats, making them a mainstream renewable technology.
As you can see, this flat has a small kitchen, so if you're using kerosene, it's really smoky and unhealthy. So this stove really is a huge benefit.
Gaia's project has been so successful, it now plans to cut importation costs by assembling the stoves in Ethiopia. A local company, Makobu, has now set up a workshop making moulds for some of the stove parts. The local company is so confident of demand, it's building a factory. This will soon be the site of full-scale production of the clean cook stove bodies. They won't just be distributed to the refugee households, but sold for domestic use in Ethiopia and beyond.
Now I'm really seeing it in a way that's going all over Ethiopia and even getting attention of the government. It's in a position now to be out in other African countries. So it's like watching a baby growing.
So I can welcome Milkyas Debebe, who will give his presentation.
Thank you. Thank you all. Good morning. I'm Milkyas from Ethiopia, Gaia Association. Now I'll be presenting about the clean, safe ethanol stove for Ashden refugees in Ethiopia. So Gaia Association was established in 2005 with a mission of promoting ethanol for household energy. And this stove will create really a big benefit for the refugees, starting from the reducing indoor air pollution. And currently we have our projects in the United Nations High Commission for Refugees, refugee camps and Addis Ababa housing developments. So generally, to see the energy conditions in Ethiopia, we are mostly dependent on the biomass use for fuel wood. And this resulted for a high deforestation and the degradation of our lands and trees. And from the result that we got, it happened to be that we lost 550,000 tons of grain due to the usage of charcoal as a fuel instead of as a fertilizer. Specifically to see the energy crisis in the refugee camp, the camp is a home for nearly 17,000 refugees, and these refugees don't receive the stove upon arrival. So they have to go out and collect firewood from the bush. And this resulted the environment to be degraded, and women face lots of gender-based violence. So we have had lots of barriers while we were trying to disseminate the stoves in the refugee camps and elsewhere. From those, we had lack of training of the technology, introducing the technology, and we are limited to disseminate the information and the technology since it was a new invention, and there was lack of awareness. We had financial constraints, and we had a communication problem with other organizations, governments, and NGOs. So specifically, when we come to Gaia Association, what it has done to overcome these barriers, what we have done is we have communicated with the private company called Makobu to eventually be the manufacturer of the stove locally. Currently, we are importing the stove from from Slovakia. And we have conducted a thorough pilot study, as you have heard from the film. And this resulted in a high acceptance of the stove and the technology by the government and by the people of Ethiopia. And we have been working closely with the government to overcome the policy barriers. So far we have disseminated 1,850 stoves, which fully scaled up the first camp in Eastern Ethiopia. And now we are in the second camp with 800 stoves to be disseminated, but already we have the stoves already in the refugee camp. And so far we have commissioned a business plan to see how the business will be sustainable. And we have created a market for the stove and for the fuel. So this stove, you see here the clean cook stove, and it has an equivalent of CO2 saving of 4 tons per year per stove. And it reduced averagely, carbon monoxide is reduced by 79%, and particulate matter is reduced by 94%. The deforestation reduced, of course, at least 2.8 tons of fuel wood per stove. And ethanol produced from the molasses, which, as you have seen in the film, from the waste product from sugar production. And it has an impact it has no impact in Ethiopian context. When we produced ethanol, we are producing it from the molasses, which is the byproduct. So it has nothing to do with any food production. So to see the benefits of the stove in the refugee camp, since they don't have to go out and collect firewood, they are relieved from, and they save their time because it takes at least more or less 2/3 of the day to collect firewood, so that they can use the time for education. And of course, indoor air pollution is reduced and environmental degradation is reduced. So to conclude, the ethanol for cooking has potential for revolutionizing household energy, especially in developing countries, with substantial benefits. And we conclude that this stove should be included in UNHCR ration kit as a non-food item. And the barriers for dissemination of improved biomass technology must be addressed simultaneously. Thank you.
Thank you very much. Very inspiring work. Tremendous in a very difficult part of the world. The final presentation in this session is from Technology Informatics Design Endeavour in India.
Bangalore, India, the heart of the country's technology boom. It's fueled by a demand for hardware and software. Yet for traditional industries in South India, the fuel most often used is the most ancient, wood. Small industries usually operate using traditional and inefficient stove designs. Now a range of specially designed burners for different industries are using less firewood and can even burn agricultural waste. It's not just better for the environment, it's boosting business. Population increase is adding to the pressure on fuel wood, and forests are now threatened. Svati Bhogle heads a team designing stoves especially for business, where the improved efficiency means real cost savings.
We were shocked at the amount of abuse of firewood that was going on, and lack of concern, apathy, ignorance, and we said that we must intervene.
She decided to tackle the businesses that use wood and other biomass as a fuel.
Basically, we are addressing the artisanal industry sector, and we are addressing the cooking needs of roadside and street food people, plus in large institutional cooking. These are all very skilled people, especially if you go to our silk reeling sites, you find enormous amount of skill, which is not easy to come by.
Engineers ensure that the new stoves don't mean retraining a generation of workers, so the stoves are designed with local needs in mind. They can even burn agricultural waste like coconut husk.
The three things which we have addressed in the technology is air-fuel ratio so that we get higher temperatures. We've looked at good insulation so that we curb losses to the environment. And we have looked at complete combustion so that there is no carbon monoxide emissions.
The new stoves can cook the same amount of food as traditional designs, but in a third of the time and using less than half the fuel. The project is getting the message across on possible savings, and even cautious business owners are now signing up.
At first we didn't bother with the new stoves, but we were encouraged to apply for them. There's a big reduction in wood use and it's easier to work with. Time has been saved. I only use 25% of the wood now, so I've made a lot of savings. Roka is now employed here to help with the lunchtime food, as she needs the work to help her family.
It's not just great for restaurants, going green is benefiting other industries. Textile dyeing demands constant hot water, making an uncomfortably hot working environment. The new stoves reduce the heat loss and cut the amount of fuel. Dixit, project engineer for Tide, is there to see the stoves are working according to plan.
What happens here is the air and the fuel ratio is being mixed properly, so the consumption of fuel is being reduced.
There are 3 types of benefits. 1, there is no smoke. It's not there. Number 2, they are able to get hot water faster, and so their work has improved. And 3rd, the drudgery in terms of feeding wood into the oven is now reduced.
Now with the new stove my health is good, and in the morning, by the time I come to work, the stove is already working, and the work is very quick. I'm very happy with the new stove.
Entrepreneurs are trained to make and sell the stoves and give advice to local salespeople, small businesses and factory owners.
We identify local entrepreneurs, train them in the production of these devices, help them in setting up the supply chain, and then we transfer the entire business to them.
I was initially trained by Tide. Now I have my own business at Kumarapalama. I'm selling products for the textile sector, like 450-litre water heaters.
450 litres water heater.
The potential market for the stoves that keep the heat and smoke out of the workplace is clear, but the challenge is meeting the demand.
Our future plans are constantly evolving. We must now concentrate on scale. Go from 1,000 to 100,000. We need a different institutional mechanism. It has to be factory made and it has to be moved through a well-organized supply chain. We are working towards that.
So I can just introduce Svati Bhogle, who will give her presentation.
Thank you. It's a pleasure to be here. You've had an excellent exposure to the work that we have done. Through this presentation, plug in some of the points that have been, could not have been communicated in those 5 minutes. A bit of a beginning about Tide, I think we have conceived ourselves as a link organization between research and the end users of technology, who are largely the neediest sections of society. We had been motivated in this direction by our mentors at the Indian Institute of Science, Professor Amulya Reddy, Professor Lokras, Professor Jagdish, who told us about the duties of a socially engaged scientist. And we were eager learners. We have been working in the area of technology, for energy, water, livelihoods, and also in the area of energy entrepreneurship. We believe that the end point of research was not just a research publication, but the commercial exploitation of the fruits of research. Some of these photographs would show you the kind of stoves that are being used conventionally. These kind of stoves made our tasks both easy and difficult. Easy because we know that the challenges to technology were not so intense, but also difficult because we knew that there has been no history of energy use reform in any of the 12 sectors where we have worked. Also, the fuel was different at different points of time. Depending upon the season and depending upon the region, we had to adapt So these are the different kinds of fuel that we had designed stoves for. Also, a stove needed to move from one fuel to another, and we had to bring in that flexibility into the design. Our energy intervention strategy was participatory. We had a product coming out of a research institution, but we needed to adapt it to the local environment. And what was the best way to do it other than involve the local artisans in the design process? So that is what we did, and these photographs capture a participatory technology development exercise. This is, in these particular pictures show the PTD exercises in jaggery making, where we work along with the artisans, and then they come to a level where they say the stove is fine and we are happy with it. But having got a good design, we needed to find how we could make best use of it. So we still had to do a little bit of tinkering with the technology, with the product, to make sure that it is in a manner that could be produced locally. These pictures are the stoves for institutional cooking and for the textile industry, for street food vendors. The major reason why we have been able to achieve efficiencies is because of high temperatures, high combustion efficiencies and heat transfer efficiencies, and reduced surface and chimney losses. Regretfully, we have had to make some technical compromises, but we realized that as the sector is getting into energy use reform, we would be able to initiate and introduce even more efficient stoves. Having got a product, it was necessary for us to sell it to the end user, and we needed to devise mechanisms by which we could sell it to the local markets. And this was not we knew that our local markets had low literacy, had low mobility. We had to go to them instead of they coming to us. So the techniques that we used were that we influenced opinion leaders, we used vehicle campaigns, we introduced entrepreneurs. In fact, our entrepreneurs were with us right from the stage of participatory technology development. And one thing we were very clear was that we should not be subsidizing the product. We've had in the past experiences which suggest that a subsidy kills a good idea. Some of the quantifiable outputs that we have achieved from the time we started these activities in these sectors, that we've intervened in 12 industry sectors: textile, sericulture, areca nut, spice drying, herbal medicine preparation, and we've sold about more than 10,000 stoves to these industries. We estimate through our own fuel accounting system that the total fuel that we've saved is about 114,000 tons, and the CO2 abated was about 200,000 tons. The benefits are there both to the owners of the units who have purchased our equipment as well as to the workers in these units. The workers say that their workplaces are more safer, less hot, they are able to work quicker, and sometimes, when the productivity, when their wages are linked to higher productivity, they are taking home more incomes. On the global front, I think we've arrested deforestation to the extent that we could possibly do with our limited resources. Some of the lessons that we have learned over these years is that different stove production processes are needed for different scales of replication. Our business plan, our entrepreneurship strategy that we had developed was more empowering, was more humane, but it was not designed for scale. We realized that we needed to be more professional and more business-like, and we understood that NGOs and businesses need to coexist. Our next steps are largely in the area of financing, and we think that with a financial innovation accompanied by a technology innovation, we should go places. Thank you. We could have achieved far higher efficiencies. We were aiming for efficiency improvement to the tune of about 30 to 40%. But we realized that the product that came out of a research laboratory could even save about 80 to 90%, 100% of the fuel, cut fuel consumption by half. But if the artisanal industry and if the worker had to compromise on his skill, and then he would have rejected it. So for the sake of acceptance of technology, we have compromised largely on efficiency. We have not compromised on indoor air quality or on heat in the working environment.
Thank you. In the first place, our stove, which is promoting ethanol for household energy, was a new invention, or the idea was not there when we first started. So we had to work closely with the government, and from what they have helped us, the ethanol that we are getting for our project is from the government sugar factory. Currently, where we get the ethanol is from a sugar factory which is owned by the government. So we first actually were invited by the government sugar factory, who had a problem of supplying ethanol elsewhere. So we have been getting the ethanol from them, and that was what they have been helping us. And in the future, they have a really tremendous amount of ethanol production expansion plan, which they already include our project or using ethanol for household energy in their energy policies. Okay, thank you. For the question of sustainability, what we first did was, when we started the project, we have been importing the stove from Slovakia, a Swedish product, so the price might not be affordable for our Ethiopian economic status. So what we did was we went for local production, which could be able to cut by half price, which can be affordable for the people of Ethiopia. That's the first thing we did. In terms of ethanol, ethanol is locally produced, which doesn't have any importation tax or any added taxes. So it's still sold under the price of kerosene, which can be sustainably sold.
Would you like to?
Yeah, as far as our stoves are concerned, we've sold most of our stoves on a cost plus basis, with every entrepreneur making about 10 to 15% profit on the stoves. The only exception has been in the sericulture sector. It was an extremely poor sector with no history of energy use reform whatsoever. We started off with a subsidy of 50% of the cost of the stove, and in course of time, over 1 year and over a period of 2,000 stoves, we were able to initiate processes by which we could reduce the subsidy to 20%. We could have gone on, and in about 6 more months of time we could have reduced the subsidy totally. But at which point of time, government looked at this program and said it's very successful and put in a subsidy program. And that, I think, has killed quite a bit of our entrepreneurial initiative.
Let me say something, and I'll give the... So in our case, the key barrier or challenge for scale up is the new technology that we are introducing, and government policies or government help. That we are getting some help from the government, but we need more to scale up. Just in short.
Yeah, when we looked at actively scaling up our products and tried to achieve scale, there were a couple of barriers which we identified. One was our own mindset barrier, coming from a background of research, we had to go into a background of business. It took us about a year to overcome that mental block which we had. After that, I think we now need innovative financing and innovative business development. We would be able to be there, yeah.
In Tanzania, the government support the technical support, but they didn't support financial support. So for our project, we need further support from other stakeholders so that to scale up.
I have a question, actually for John, you might answer this. It's related to materials, and I expect the materials you're using are, say, mild steel. And the question is, did you have any problems of the stove, the material actually burning through, oxidizing, and also probably a question also for Svati later.
Okay, the material we used is not a big problem, but the problem is the way to produce more stoves to meet the market. The mild steel is not a problem. The problem is production of a number of stoves is problem to us. We have got a big market, but we didn't satisfy the market. That's the problem, not mild steel material.
Yeah.
Thank you.
Thank you. The question was relating to whether you had a problem with materials and particularly burning through with the.
We found that burning wood and biomass with mild steel as the material of construction, especially with high temperatures and moistures, was a problem. But we overcame it with an insulation lining. We always protected the equipment, the mild steel, with some insulation material. If we didn't, we found that the life was not more than 2 years.
In our country, sawdust stove is plenty. Everywhere is sawdust, piles and piles. And our stove didn't use only sawdust, but also use rice husks. So we didn't expect that the stove will come a day, it will come a day that will stop, because our stove is using sawdust stove, using sawdust waste from pine trees, which are grown in a large number in our country for timber and other economic use. So we didn't expect so, because we are planting and harvesting it sustainably. So we didn't expect so.
Yes, so does collaboration
with
often between different groups?
Yes, we have collaborated with other groups and with government. The government provide us a lot of opportunities to participate in national trade shows and regional trade shows, and sometimes in East African countries. So we collaborate with government and our national technology development, CEDO. CEDO also collaborate with us on technology transfers and promotion of our stoves, but they didn't provide us funds for scaling up.
Thank you. So we'll close the session now, and if I could just thank all the presenters, tremendous presentations and answering the questions very clearly. Thank you very much.